5.0.0, laying out branch circuits and sizing outlet boxes. Describe how to complete a branch circuit layout for power. Describe how to complete a branch circuit layout for lighting. Describe how to install outlet boxes. And then there's a performance task to select the proper size and type of outlet box needed for a given set of wiring conditions. The point at which the electrical equipment, appliances, and devices are connected to the wiring system is commonly called an outlet. There are many classifications of outlets. There are lighting outlets, receptacle outlets, motors, appliances, and so forth. This section discusses the power and lighting outlets typically found in residential electrical wiring systems. So an outlet is just that, a place where we take the electricity out of the wiring going to the utilization equipment, whatever that equipment is. 5.1.0, branch circuit layout for power. Here's a highlight. It says figure 52, typical outlet symbols appearing in electrical drawings. So there's a single receptacle outlet. There's a duplex receptacle outlet. There's a split wired duplex receptacle outlet. And these are three or 240 volt, 3-wire. Range receptacle 50 amp, dry receptacle 30 amp. There's a special purpose outlet, and that can be whatever is determined by the architect to be a special purpose outlet. It might be a twist lock. Maybe it's in the garage in the work area overhead to keep cords out of the way, but it needs to be a twist lock in order to make sure that the plugs don't unplug themselves. 5.1.1, branch circuits and feeders. Branch circuits are the conductors that run from the panel board to the outlets. NEC defines them as the point of the wiring system that extends beyond the final overcurrent device protecting the circuit. Figure 53, you can see the components of a duplex receptacle branch circuit. So feeders, we've said this before, go between overcurrent protection devices. In fact, some people call the load side meter wiring that goes from the load side of the meter socket into the house to the panel as a feeder. And if you have a sub panel, the wires going from an overcurrent protection device to that sub panel is a feeder. And a lot of people consider if you have outdoor air conditioning unit, a compressor, if you put a fused disconnect at that compressor, the wires feeding that fused disconnect are a feeder. The wires that go from the load side of that fused disconnect to the compressor is a branch circuit. The branch circuit runs from the final overcurrent protection device to the utilization equipment. So branch circuits and feeders. Here's the neutral bus. There's one on both sides of this panel, and they're tied together. Then they have grounding bus bars on both sides. And because this is the first means of disconnect, the grounding bus bar and the grounded bus bar for the neutrals are in common. And these are the circuit breakers, and these are the ungrounded conductors coming off of the circuit breakers going out to the different loads. So here, branch circuit wiring. The hot and the neutral are considered current carrying conductors. The equipment grounding conductor is not considered a current carrying conductor. Under normal circumstances, there should be no current flow on the grounding conductor, the equipment grounding conductor. All of the power going out in the ungrounded conductor should be coming back on the neutral conductor. If there's any imbalance between the two, that's when your ground fault circuit interrupter will detect that and it'll trip. It'll disconnect it from the power. So it says the feeders, the conductors that run from the service equipment to other sources such as a generator and the panel board. NEC Article 100 defines feeder as the circuit conductors between the service equipment, the source of a separately derived system, or other power supply sources, and the final branch circuit overcurrent device. That's what we were saying before. So if you go from an overcurrent protection device to a sub panel, like this sub panel, these are feeders. So this says that one is a feeder. Two are the neutral bus. These are the neutral buses in the main panel. These are the neutral buses in the auxiliary panel or the sub panel. Notice how they have a grounding bus bar in the sub panel that is isolated from the neutral bus bar. You can't tie these two together. So in the first panel, the main panel, the grounding bus bars and the neutral bus bars are connected electrically. In the sub panel, they are not. They're isolated. And the neutral bars are isolated from the back plane of the panel. They're on Bakelite or some kind of insulators so that they do not make electrical contact with the back plane of the sub panel. So from the circuit breaker, we have the ungrounded conductor and the neutral conductor. 4 is the ungrounded, the branch circuit. 5 is the grounded conductor, the neutral. 6 is the equipment grounding conductor. And 7 is the duplex receptacle. And 3 is the ground bus, in case I didn't spell that out. So in general, it says the size of the branch circuit conductors varies depending on the load requirements of the electrically operated equipment that'll connect to the outlet. For residential use, most branch circuits consist of either a 14 gauge, 12, or 10, or 8. Fractional horsepower motors and small electric heaters usually operate at 120 volts and are connected to a 120 volt branch circuit by means of a receptacle, junction box, or direct connection. Let's go on. I don't want to read the whole book to you. Types of branch circuit lines shown on electrical working drawings, figure 55. It says here, the lines indicating branch circuits shall be solid to show the conductors that are run concealed in ceilings or walls, dashed to show the conductors that are to be run in the floor or ceiling below, and dotted to show wiring that is to be exposed. Figure 55 shows examples of these 3 types of branch circuit lines. So this solid conductor is in the walls. They're saying this dashed conductor can be in the ceiling below, if this is the second floor. And these are home runs. The home run has arrowheads, and it shows you that it's going back to the panel. And it shows the number of ungrounded conductors. Usually it'll have a long for the neutral and then 2 shorts for the ungrounded conductors. They don't show the ground, the green, the equipment grounding conductor. And then here's a dotted line. They said that this was exposed. Maybe this is in the garage and it's overhead and it's exposed and it's going to the panel A. So 1 is a solid line, shows the branch circuits running from the panel board to outlets or between outlets. These runs are concealed in the ceiling or the walls. And 2 dashed lines show conductors that run concealed in the floor or the ceiling. So they ran past a doorway, so they needed to go in the ceiling above the doorway. And 3 are slash marks indicate the number of current carrying conductors. 3 slash marks indicate 3 current carrying conductors, 2 non-grounded conductors, and 1 grounded conductor. So if there are no slashes to indicate 2 current carrying conductors to complete the circuit. So this is 3 current carrying conductors, 1 neutral and 2 ungrounded conductors. Again, the drawings I've seen, they'll make the neutral longer. The 2 ungrounded conductors will be a little shorter. And then 5, it says some wiring methods require protection from physical damage. Examples are non-metallic sheath cable, type NM cable, is in NEC section 334.15b. And 6 is panel board A. Panel boards are differentiated from one another with letters. 7 is the typical receptacle symbol. So here's your typical receptacle symbol. That's a duplex receptacle. Warning, never assume you know the meaning of any electrical symbol. Architects, consulting engineers, and electrical drafters change symbols or create new ones to meet their own needs. You should always check the symbol list or legend for the meaning of the symbols on that set of electrical working drawings. 5.1.2, locating receptacles. Okay. An outlet is the point of utilization where you connect the electrical equipment, appliances, and devices to the wiring system. And I'm going to make that a highlight, and we're going to go look in our code book. Um, Article 21052 tells us everywhere in a residence that we need to have receptacles. 21070 tells us everywhere we have to have switches. So there are some rules governing exactly where we put those receptacles and switches. NEC section 21052 states that in each kitchen, family room, bedroom, living room, dining room, den, library, sunroom, or similar area, receptacle outlets must be installed so that no point along the floor line in any wall space is more than 6 feet. Measure horizontally from an outlet in that space. This makes the receptacle spacing not more than 12 feet. We call it the 12-foot rule. The code book doesn't say 12 feet. The code book says not more than 6 feet. But let's see here if we can see figure 52. Now, that's not what I wanted. All right. If you can get, here, let me show you here. I think I've said this before. Here's a room. Where's my ink here? Let's get some ink. So here's my room. Here's my door. Oh, that's horrible. What happened? And let's say this is a closet. And let's say this is, and I'm not going to bother putting the windows in. There are windows, but we don't worry about the windows. We put the receptacles below the windows or on the side of the windows. Within 6 feet of this doorway, we have to have a receptacle. And now we can get 6 feet away from the receptacle and still be in compliance to code. And if we're within 6 feet of the next receptacle, we've never been further than 6 feet away from a receptacle. But the receptacles are 12 feet apart. So we electricians call it the 12-foot rule. And then we'll go 6 feet, another 6 feet, we'll put another receptacle. Now, let's talk about convenience, because here we've spaced these 12 feet apart, and if it's more than 6 feet to this corner of the room, then we would have to put a receptacle here in the corner. And within 6 feet of, here, let me get my eraser, erase this little line here where I made a mistake. If we can get 6 feet away from the door on this side, we need a receptacle on this wall. We don't want to take cords across doors, fireplaces, or openings of any kind. We don't want them to be a tripping hazard, so we'd have to put a receptacle on this wall as well. And any wall space 2 feet or greater has to have a receptacle. Now, talking about convenience, what if I put my bed right here? Maybe it's a queen-size bed. Well, now I can't get to my receptacle. It's behind the baseboard. So what would be more convenient for the homeowner is if when we're laying these receptacles out, we go ahead and put one over here in the corner, even if it's only 8 feet away from the first receptacle. And then we'll measure 12 feet. And this other one will end up in a corner, and then we'll measure 12 feet, and we'll put the last one over here at within 12 feet of this receptacle. And hopefully we're within 6 feet of this wall space here. That way, when we put our bed either up against this wall, or if we want to put it up against this wall, we can put end tables. Here, let's see here. Here's a nice brown color. We can put a nice brown color or a nice end table. There you go. And we can put lamps on the end tables, and we can plug those lamps or our clock radio or whatever we have, our phone charger. We can get to that receptacle instead of having to go behind the baseboard. So for convenience sake, we may want to put a little bit better spacing on these. We would want them to be closer to the corners. And yes, some people do want to put their bed in the corner. If that's the case, then they would have to plug into this receptacle. But I've more often seen it that the beds are in the middle of the wall with end tables to either side and a dresser on one side, maybe on both sides. All right. So let's go to the code book. It says with this NEC requirement in mind, outlets for our simple residents are laid out in Figure 56. On laying out these receptacle outlets, the floor line of the wall is measured, including round corners, but not across doorways, fireplaces, passageways, or other spaces where a flexible cord extending across the space would be unsuitable. It would be a tripping hazard. So they start at the door, and within 6 feet, they put a receptacle. This is actually a utility room. So you don't have to have one every 6 feet in a utility room. The habitable rooms, kitchens, dining rooms, bedrooms, bathrooms, living rooms, parlors, sunrooms, dens, things like that. You have to have them every 6 feet. The kitchen is a little different because we're going to have counter space. We're going to have receptacles above these counters. And in a case like that, you don't want to be further than 2 feet away from a receptacle. So we're going to put them every 4 feet on top of the counter space in the kitchen. And any wall space greater than 12 inches or more, will have a receptacle. That keeps us from plugging something in and stretching a cord across the range or across a sink. We don't want our cords going across these things. Okay. So, no point along the wall space shall be more than 24 inches of receptacle outlet on the countertops and work surfaces in kitchens and similar areas. Receptacle outlets installed in kitchens shall be GFCI protected. You have to have a minimum of 2 small appliance branch circuits. All 125 volt, 15 and 20 amp receptacles specified in NEC section 21052 shall be listed as tamper resistant per NEC section 406.12. So tamper resistant means that you can't push something into the ungrounded conductor like a paper clip and get hurt. You have to plug something in both sides at once, the hot and the neutral, or the ungrounded and the grounded prongs. They have to go in at the same time, and then they'll open a window. There's a little plastic door that's in the way, and it'll open up and allow that plug to plug in. Bathroom receptacles must be on a separate circuit protected by GFCI. Receptacle outlets shall be installed such that no point measured horizontally along the floor line is more than 6 feet from a receptacle outlet. This generally applies to habitable rooms. Since duplex receptacle outlets must be no more than 12 feet apart, a 6-foot extension cord will reach a receptacle from any point along the wall line. Note that at no point along the wall line are any receptacles more than 12 feet apart or more than 6 feet from any door or opening. Where practical, no more than 8 receptacles are connected on one circuit. However, this is just a design consideration because general purpose receptacles in dwelling units are sized based on 3 volt amps per square foot. So, and here they're saying, for example, a 15 amp branch circuit times 120 volts is 1800 volt amps. NEC requires that for every 600 square feet of dwelling space, you must install a circuit to supply lighting and receptacles. So 1800 volt amps divided by 3 volt amps per square foot equals 600 volt amps, 600 square feet. Okay. One duplex receptacle is located in the foyer for cleaning purposes, such as feeding a portable vacuum cleaner or a similar appliance. It's connected to the living room circuit per NEC section 21052I. An additional duplex receptacle is required per NEC section 21052H in hallways that are 10 feet long or longer. Although this is not shown, the living room outlets could be split wired, which means the lower half of each duplex receptacle is always energized and the upper half can be switched on or off. The reason for this is that a great deal of the illumination for this area would be provided by portable table lamps. Split-wired receptacles would provide a means to control these lamps from several locations, such as at each entry to the living room if desired. Split receptacles are discussed in more detail in section 5.1.3. And it's an exception to the code that says that all habitable rooms have to have a lighting circuit. And then there's an exception that says in lieu of a circuit dedicated to lighting, you can switch a receptacle in that area and it will count as the lighting circuit for that area. A lot of contractors do that because it's a lot less expensive to just half switch one of those receptacles than to run a lighting circuit in the center of the room. So let's review. Let me go to the code book and let's see what the code book says about this. So here's our NFPA 70 2023. And if we go to the code, we'll see that Article 210 is required outlets. Part 3, required outlets. So branch circuits not over 1,000 volts, AC, required outlets, page 86. Let's go see page 86. There. Required outlets. 21052, dwelling unit receptacle outlets. This section provides requirements for 125 volt, 15 and 20 amp receptacle outlets. Receptacles required by this section shall be in addition to any receptacles that are for part of a luminaire or appliance or controlled by a listed wall-mounted control device in accordance with 21070A1, exception 1, or located within cabinets or cupboards, or located more than 5.5 feet above the floor. General provisions in every kitchen, family room, dining room, living room, parlor, library, den, sunroom, bedroom, recreation room, or similar room or area of a dwelling unit. That means any habitable room. We can't list all of the habitable rooms. We don't know what you're going to call it. Maybe you have a conservatory, maybe you have a sunroom, or maybe you have you might have a room that you call something else. They're saying, or similar room or area, meaning all rooms of a house, shall be installed in accordance with the general provisions specified in 21052A1 through 4. Spacing. Receptacles shall be installed such that no point measured horizontally along the floor line of any wall space is more than 6 feet from a receptacle outlet. What's a wall space? Well, a wall space is any wall that's 2 feet or greater. As used in this section, wall space shall include the following: any space 2 feet or more in width, including space measured around corners, and unbroken along the floor line by doorways or similar openings, fireplaces, stationary appliances, and fixed cabinets that do not have countertops or similar work surfaces. The space occupied by fixed panels in walls, excluding sliding panels. So if you have, you're rich and you live on the ocean and you have 24 feet of window space, floor to ceiling, that you can look out at the ocean. If those panels don't move, they're a wall, and you have to have receptacles every 12 feet. You can't install it in the glass wall. You have to install it in the floor within 18 inches of that wall. But those outlets that are within 18 inches of that wall will count as the walls for the continuous wall space. Now, if those 24 feet panels, if they slide, if you can open them all up to feel the nice sea breeze coming in, they're now a door. They're not a wall. If they're movable, you don't put receptacles in front of doorways. So you wouldn't need any receptacles in front of that entire 24-foot space. You'd need an outlet within 6 feet of the edges of that 24 feet space. But if they slide, they're a door. If they're fixed and permanent, it's a wall. So, space occupied by fixed panels and walls, excluding sliding panels. The space afforded by fixed room dividers, such as freestanding bar type counters or rails. And then it goes on to talk about small appliances, receptacle outlets served in the kitchen, pantry, breakfast room, dining room, or similar area of a dwelling unit. The 2 or more 20 amp small appliance branch circuits required by 21011C1 shall serve all wall and floor receptacle outlets covered by 21052A. All countertop outlets covered by 21052C and receptacle outlets for refrigeration equipment. What that's saying is that those rooms have something to do with eating. That's the way you can think about it. A kitchen, a pantry, a breakfast room, a dining room. These are rooms, if you have a breakfast nook, if it's anything that has to do with serving or food or eating food, those are the areas that the two 20 amp small appliance branch circuits can serve. You don't want to try to do too much with those two 20 amp small appliance branch circuits, so you might want to throw in a third 20 amp small appliance branch circuit. You can always go better than the code. You can put more. Okay. And then in here it says exception, and this is one of the exceptions that I live by, that don't put the refrigerator on one of the two 20 amp small appliance branch circuits. Okay. In addition to the required receptacles specified in 21052, switched receptacles supplied from a general purpose 15 or 20 amp branch circuit shall be permitted in accordance with 21070A1, that's for lighting. In addition to the required receptacles specified in 21052, a receptacle outlet to serve a specific appliance shall be permitted to be supplied from an individual branch circuit rated at 15 amps or greater. And then it says, here I should make this bigger, no other outlets. The 2 or more small appliance branch circuits specified in 21052B1 shall have no other outlets. Exception number 1, a receptacle installed solely for the electrical supply and support of an electric clock in any of the rooms specified in 21052B1 shall be permitted to be served by a small appliance branch circuit. So in the 60s, it was a fad. Everybody had a clock in their kitchen. That clock ran on 120 volts. So you had a clock outlet. That outlet was for the support of and the power to that clock. So it was called a clock outlet. And you could put that on one of the two small appliance branch circuits. Exception number 2, receptacles installed to provide power for supplemental equipment and lighting on gas fire ranges, ovens, and counter-mounted cooking units shall be permitted to be served by a small appliance branch circuit. So if you have a pilot switch that's going to ignite your gas range, you can feed that from one of the two small appliance branch circuits. Kitchen receptacle requirements. Additional small appliance branch circuits shall be permitted to supply receptacle outlets in the kitchen and other rooms specified in 21052B1. No small appliance branch circuit shall serve more than one kitchen. So if you have 2 kitchens, you need 4 small appliance branch circuits. Here's countertops and work surfaces, just like in the house, but this is every 2 feet, so it's 4 feet apart. In kitchens, pantries, breakfast rooms, dining rooms, and similar areas of dwelling units, receptacle outlets for countertop and work surfaces that are 12 inches or wider shall be installed in accordance with 21052C1 through C3 and shall not be considered as the receptacle of outlets required by 21052A. Wall space. For the purpose of this section, where using multi-outlet assemblies, each 12 inches of multi-outlet assembly containing 2 or more receptacles installed in individual or continuous lengths shall be considered to be one receptacle outlet. Receptacle outlets shall be installed so that no point along the wall line is more than 24 inches measured horizontally from a receptacle outlet in that space. So they have to be within 4 feet of each other. The location of the receptacles shall be in accordance with 21052C3. And then we have some exceptions. Receptacle outlets shall not be required directly behind a range, a counter-mounted cooking unit, or sink in the installation described in figure 21052C1. Where a required outlet cannot be installed in the wall areas shown in Figure 21052C1, the receptacle outlet shall be permitted to be installed as close as practicable to the countertop area to be served. The total number of receptacle outlets serving the countertop shall not be less than the number needed to satisfy 21052C1. There's an exception in here, I may not find it, that says that the receptacles have to be installed above the countertop, and the exception is they can be mounted below the countertop to meet the requirements of the Americans with Disabilities Act. So if someone's in a wheelchair and their countertops are lower, they're not going to put the receptacles back on the wall above the splash guard. They're going to put them underneath the counter where there's at least a 6-inch overhang of counter. Those receptacles will be reachable underneath that counter space so that that handicapped person can wheel up to it and plug in appliances and use those. Island and peninsular countertops and work surfaces, receptacle outlets, if installed to serve an island or peninsular countertop or work surface, shall be installed in accordance with 21052C3. If a receptacle outlet is not provided to serve an island or peninsular countertop or work surface, provisions shall be provided at the island or peninsula for future addition of a receptacle outlet to serve the island or peninsular countertop. I think the dimensions were 12 inches by 24 inches. If your island was larger than 12 inches by 24 inches, you had to have at least one outlet in that island. And same with the peninsula. If the small dimension was 12 inches by the large dimension was 24 inches, you have to have a receptacle somewhere in that peninsula. Okay, let's go back to the book. I don't want to get too bogged down. These are their drawings that were saying if this is a range or a sink, you need not put any receptacles back on this wall. There's an area behind the receptacle, the sink or the countertop range. You needn't install any receptacles in that area. Okay. All right. Well, let me just read this real quick. They go on to talk about laundry areas. It says balconies, decks, and porches. Balconies, decks, and porches that are within 4 inches horizontally of the dwelling unit shall have at least one receptacle outlet accessible from the balcony, deck, or porch. Receptacle outlet shall not be located more than 6.5 feet above the balcony, deck, or porch. Laundry area in dwelling units, at least one receptacle outlet shall be installed in areas designated for the installation of laundry equipment. Those, remember when we were doing the calculations, we had a minimum of 2 small appliance branch circuits in the kitchen and at least 1 laundry branch circuit. This is that laundry branch circuit. They're saying that it has to be installed for that laundry equipment. Basements, garages, and accessory buildings have to have at least 1 per car. For 1 and 2 family dwellings and multifamily dwellings, at least 1 receptacle outlet shall be installed in the areas specified in 21052G1 through 3. Garages. In each attached garage and in each detached garage with electric power, at least 1 receptacle outlet shall be installed in each vehicle bay and not more than 5.5 feet above the floor. So if you have a 2-car garage, you have to have 2 receptacles. If you have a 10-car garage because you're rich, then you don't need to be taking this class. Now, you would need 10 receptacle outlets, 1 for each bay. And same with lighting. You need a lighting outlet for each bay. Accessory buildings in each accessory building with electric power. Basements in each separate unfinished portion of a basement. Hallways and dwelling units, hallways 10 feet or more in length shall have at least 1 receptacle outlet. Foyers that are not part of a hallway in accordance with 21052H and that have an area that is greater than 60 square feet shall have a receptacle located in each wall space 3 feet or more in width. Doorways and door side windows that extend to the floor and similar openings shall not be considered wall space. Okay, all right.